In this section, you will learn how changes in scientific thought during the 16th and 17th century gave Europeans a new way to view the universe and their place in the universe. Medieval scientists were known as natural philosophers, and they didn't make observations about the natural world, however. What they did was they relied on a few ancient philosophers like Aristotle for their scientific knowledge. Now, in the 15th and 16th centuries, natural philosophers began to give up their old views, and they started to develop some new views. Renaissance humanists had learned Greek and Latin, and they were able to read Ptolemy, Archimedes, and Plato. And as they read them, they knew that these writings made it obvious that some of the ancient thinkers actually disagreed with Aristotle. At the same time, the invention of new instruments like telescopes and microscopes made new scientific discoveries possible. And it was the printing press that made new ideas spread quickly and easily. Mathematicians played an important role also in the scientific achievements of the 16th and 17th century. Nicholas Copernicus, Johannes Kepler, Galileo Galilei, Isaac Newton, these are all great mathematicians, and they all believed that the secrets of nature were written. Okay, so I'm going to want you to fill out this chart here on revolutions in astronomy. First, we're going to talk about Copernicus. Nicholas Copernicus of Poland published his famous works on the revolutions of the heavenly spheres in 1543. He believed his heliocentric, or with the sun in the center, system was more accurate than the Ptolemaic system. Copernicus argued that all the planets revolved around the sun, and the moon revolved around the earth, and the earth revolved on its axis. The German mathematician Johannes Kepler also helped destroy the Ptolemaic system. His observations confirmed that the sun was at the center of the universe, and he tracked the elliptical orbits of the planets. Ptolemy had insisted that the orbits were circular. The Italian scientist and mathematician Galileo Galilei answered one of two remaining questions for the new astronomy. What were the planets made of? He was the first European to make regular observations with a telescope. He saw mountains on the moon and 4 moons orbiting Jupiter. Ptolemy had said the heavenly bodies were pure orbits of light, but now it appeared that they were material. The capstone to the 17th century scientific revolution came with Newton's argument for the framework of natural laws. In his Principia Mathematica, he established the principles of motion, defined the forces of gravity, and redefined the principles of scientific methodology. Sir Francis Bacon emphasized the arriving at conclusions about nature using inductive reasoning, or making generalizations from particular observations and experiments and organizing them to test hypotheses. He developed the scientific method, and he believed that science was to give, the purpose of it was to give humankind new discoveries and the power to serve human purposes by conquering nature in action. The control and domination of nature became the primary concern of science and all the technology that followed it. In the 16th century, scientific research followed late medieval patterns. Copernicus, through astronomical observation and mathematics, disproved the belief that the Earth was the center of the universe. He knew that the classic Greek view of the Earth as the center did not mathematically allow for the calculation of planetary motion. The appearance of new instruments allowed advances in both biology and astronomy. Galileo publicized Copernicus's findings, and Kepler later proved more accurate reaffirmation of his work. Galileo's condemnation of the Catholic Church demonstrated the difficulty traditional religion had in dealing with the new scientific attitude. William Harvey explained the circulatory system of animals. The advances were accompanied by improved scientific methodology. Bacon urged the value of empirical research, and Descartes established the importance of a skeptical view of all received wisdom. I think, therefore I am. The capstone to the 17th century scientific revolution came with Newton's argument for the framework of natural laws. In his Principia Mathematica, he established the prime principles of motion, defined the forces of gravity, and redefined the principles of scientific methodology. The revolution in science spread quickly among the educated, which witchcraft hysteria declined, and a belief grew that people could control their environment. New attitudes towards religion resulted. Deism argued that God did not regulate natural laws. Locke stated that people could learn all that was necessary through their senses and reason. Wider's assumptions about the possibility of human progress emerged. In all, science had become central to Western intellectual life, a result not occurring in other organizations. In the late Middle Ages, medicine was dominated by the teaching of the Greek physician Galen, who lived in the 2nd century A.D. His views about anatomy were often wrong because he used animals, not people, for dissection. The new anatomy of the 16th century was based on the work of Andreas Vesalius, published in his On the Fabric of the Human Body. He reported his results from dissecting human bodies as a professor of surgery at the University of Padua, presenting an accurate view of the individual organs and general structure of the human body. He erroneously believed that the body had two kinds of blood, however. William Harvey's On the Motion of the Heart and Blood, in 1628, showed that the heart, not the liver as Galen had thought, was the beginning point of the blood circulation. He also showed that the same blood runs through veins and arteries, and that the blood becomes a complete circuit throughout the body. Harvey's work was based on close observation and experimentation. The work of Robert Boyle in chemistry was also based on close observation and experimentation. He formulated Boyle's law about gases, that the volume of gas varies with the pressure exerted on it. In the 18th century, Antoine Lavoisier, the founder of modern chemistry, invented a system of naming the chemical elements, or the periodic chart. It's time for a reading check. Stop the movie now and think about everything that's been said up to this point. Get your notes filled in, and close your notes when you're done, and think about all of the things that we've talked about up to this point, and put them all in your own words, and think about what possibly you might find to be on the test. Also, you can also consider, how did Vesalius and Harvey disprove many of Galen's theories? When you're finished with this, turn the movie back on. Welcome back. One of the most prominent female scientists of the 17th century was Margaret Cavendish. In works such as her Observations upon Experimental Philosophy, she criticized the belief that humans through science were the true masters of nature. In Germany, many women scientists were astronomers. They often received training in their family observatories or from their husbands or fathers. Maria Winkelmann was the most famous of these. She assisted her husband, the famous Prussian astronomer Gottfried Kirch, and discovered a comet. Winkelmann was denied a post as assistant astronomer at the Berlin Academy because of her gender. In the view of most people of the 17th century, science and scholarship conflicted with the domestic roles women were expected to fulfill. The work of the French philosopher René Descartes strongly reflected the Western view of humankind that came from the scientific revolution. In his Discourse on Method in 1637, he asserts that he can rationally be sure of only one thing, his own existence. He asserted he would accept only those things his reason said were true. Descartes asserted that while he could not doubt the existence of his mind, I think therefore I am, he could doubt the existence of the material world. He concluded that the material world and the mental world were two different realms. He separated mind and matter. This made matter something inert and independent of the observer that could be investigated by a detached rationality. Descartes had been called the father of modern rationalism. This system of thought is based on the idea that reason is the chief source of knowledge. Okay, it's time for another reading check. Think about what we talked about Descartes and women in the scientific revolution. And also ask yourself, what is the significance of Descartes' principle of the separation of mind and matter? Turn off the movie now and think about that stuff. Make sure you have that in your notes as well. Okay, we're back. I hope you really are taking some time to stop the movie and think about these things, because it's only by thinking about this stuff that you're actually going to be able to remember it for the test. It's one thing to listen to this podcast and to just kind of let it wash over you, but you've got to really think hard about this stuff if you're going to have any hope of remembering it. Okay. During the scientific revolution, people were concerned about how they could best understand the physical universe. They created the scientific method. The philosopher Francis Bacon was most responsible for this method. And Bacon emphasized arriving at conclusions about nature using inductive reasoning, or, in other words, making generalizations from particular observations and experiments organized to test hypothesis, and then using that information to make educated guesses about the larger material world. Bacon believed science was to give, the purpose of it was to give humankind new discoveries and the power to serve humans' own purposes by conquering nature. The control and domination of nature became an important concern of science and all the technology that's going to come after it. Okay, it's time for our final reading check, and I'd like you to ask yourself the following question. What are the characteristics of the scientific method? Okay, and this is going to conclude our podcast for the scientific revolution, and hope to see you on the next one.